So good evening, everyone, and this is lecture number 2 of photoelectric effect. And I remember that in the last lecture we were discussing the momentum of an electron and momentum of a photon. Yes or no? We already saw the momentum of a photon. E by c was the momentum of a photon. You can write it at hf by c or E by lambda. Yes or no? And with that momentum, I also said that since we have calculated the momentum of a photon, we can also calculate the momentum of any moving body. So I'll discuss more on that because that also covers one part, matter waves. And coming back to the question of matter waves, see, this is the question that I told you in yesterday's class, the number of photons falling per second. Yes or no? And if you remember in the yesterday's doubt class, I showed you the paper, I think of the last year or somewhere, and I showed you the same question coming there, right? So remember, just concentrate on what I am telling you, and I'm sure that the same question will land up in your exam hall. I'm pretty confident about that. Anyways, since we were discussing the momentum of a photon, and I think we got stuck with some questions because I've seen those questions come in the exam, and sometimes this topic gets skipped. We don't discuss it in detail, so I thought that I'll just take 5-10 minutes and discuss this topic of what is known as the matter waves. So we write the small heading matter waves. Now what do you mean by these matter waves? Now we have seen that light has got dual nature. Sometimes in some cases it behaves as a wave, continuous. Sometimes in some cases it behaves as particle, discrete particles. Some phenomena can only be explained by the concept of discrete particles, and we are studying that phenomena. We are going to study that phenomena in the form of photons, photoelectric effect. Some phenomena can only be explained with the concept of wave. We have seen those phenomena: interference, superposition, diffraction, polarization. We have discussed those. Now the same thing could be applied in a different way. Now let us talk about normal things like particle. This is a pen, this is a particle. I am a particle. A bus is a particle. An electron is a particle. A neutron is a particle. All these are particles because they occur in discrete packets. We are all packets, so we are all particles. Now light has dual nature. It is a wave as well as it is a particle. So why not apply this concept on things that we know are particle? So this matter waves for concept is something like this. It is a wave associated with a moving particle, not a particle which is stationary. So matter wave is a wave associated with a what? Wave associated with a moving particle. So whenever a particle, a point mass, a body, a neutron, an electron, a bus, a car, a train, a plane, a spacecraft, anything that moves, obviously photon also moves, we can call it a wave. And this wave, which is associated with a particle, you can call it matter wave, or you can also call it de Broglie wave. And also call it the de Broglie wave. So every particle, now we can assume it also has a wave nature. Light has dual nature, so every particle also has a wave nature now. Now when you talk about the wave, the first thing that comes to mind is what will be the wavelength of that wave. So what is the wavelength of this matter wave? What will be the wavelength of this de Broglie wave? So what is the wavelength for the de Broglie wave? It comes from the original concept, h divided by p. Do we understand? Comes from the momentum of the photon. The momentum of a photon is h divided by p. We have taken this concept from photon and we have put it onto a matter wave, onto a particle which is moving with a velocity v, h divided by p. So it becomes h divided by mv, the wavelength associated with a particle, h divided by mv. Now when this particle moves, it has kinetic energy, yes or no? So now I can write it in the form of this, h divided by momentum. We remember the relation between momentum and kinetic energy. So I think you remember the relation 2 times m into k, where k is the kinetic energy of the particle. Do we understand this? Yes or no?
Yes, sir.
So from that thing, we can say this lambda is inversely proportional to the momentum. If the mass is constant, we can say this lambda wavelength is inversely proportional to the speed or velocity, magnitude of velocity. This lambda is inversely proportional to 1 by root over k. Or if everything else is constant, this lambda is inversely proportional to 1 by root of m, depending on what is constant and what is not constant. This wavelength that we associate with a particle is known as de Broglie wavelength. Do you understand this? De Broglie wavelength is how it is known as. So that becomes the basic formula for a de Broglie wavelength. Now, when we talk about this de Broglie wavelength and we will try to calculate it for a moving body, it's going to come very, very less. That is why we say that this wave nature of this particle is actually very less. So we cannot take it as a wave, we have to take it as a particle. But whenever we talk about this de Broglie wavelength, obviously we will not talk about de Broglie wavelength of a moving train because it is going to come very less. When we talk about this de Broglie wavelength, we'll probably talk about de Broglie wavelength of a small particle. You can see this de Broglie wavelength is inversely proportional to the mass of the particle. Yes or no? Right? So if the particle is very small in mass, it may have some appreciable de Broglie wavelength. Yes or no? So whenever we talk about this de Broglie wavelength or this matter wave, we are talking about basically moving electrons or moving protons or neutrons. Neutrons are not charged particles though. Alpha particle and all those deuteron and all those particles. So basically when we talk about matter waves, we are talking about those particles. Now out of those particles, when we talk about the particles that come into the picture straight away are electrons and protons, and these are particles which are charged particles. Yes or no? So we can devise a formula for,
Sir,
yes beta,
sir, lambda is directly proportional, inversely proportional to 1 by m also, no, sir. Why
1
the
by root
like?
over m, 1 by root over m. Yes, what is the problem?
It is also inversely proportional to 1 by m, no, sir. Proportional to 1 by
Beta,
m.
it again depends on how you are seeing it. If the velocity, if you have two particles having the same momentum, then for them it is inversely proportional to mass. If they have the same kinetic energy, they are inversely proportional to root over m. So I wrote it in terms of kinetic energy. Should not have written this actually. We normally do not write it. So let us take this out. Okay. Now it is okay.
Okay, sir.
Okay. Chalo. So the next thing that we must understand is de Broglie wavelength of moving or de Broglie wavelength of charged particles. Now, whenever we have a charged particle, and when we talk about charged particle, we are basically talking about electrons or protons or alpha particle. We can accelerate them using an electric field. Yes or no? So we can see in the formula for de Broglie wavelength is h by p, which is equal to h by mv, which is equal to h by root over 2 times E into kinetic energy. Now this kinetic energy of this charged particle actually comes when they are accelerated by an electric field or accelerated by a potential difference. This kinetic energy, and that comes from the chapter on electrostatic energy, electrostatic force. This kinetic energy is half mv square, and you can write it as q, the charge multiplied by v, if they are accelerated by a potential difference of v. Do we know this? Yes or no? So now I can write this formula in this fashion: h by under root of 2 m q p. where V is the potential difference. Now, I hope you understand the meaning of the term potential difference. Yes or no? Potential difference, do you understand this? No? I'll give you 2 minutes to note this down.
Completed, sir. Completed, sir.
Completed, sir.
Everyone done?
Yes, sir.
Do we know the meaning of this V for potential difference? Okay.
No, sir.
2 volt, 3 volt potential difference. And just take it as potential difference. Okay. We will understand this term probably when we do electrostatics. We can't get into that term right now. Okay. So this becomes a formula. Potential difference will be given to you. You just put the values and you will get your answers. Do we understand this? This potential difference will be given in volts. So just now understand this much. That is all that we can do at this point in time. Okay. Now once you you have this formula for charged particles, because charged particles can be accelerated by electric field. Okay, if they are not charged particles, then you will have to use their kinetic energy. Their kinetic energy would be given to you. Do we understand this? Yes or no?
Yes, sir.
Now, based on the formula of this energy, you can also get a series of graphs based on this. So I will just show you that graphs, and I hope you would be able to understand these graphs. These graphs are meant for matter waves, and I hope you understand. It all comes from the proportionality sign that we had written. Lambda is inversely proportional to P. Do we understand graph number 1? Sort of a rectangular hyperbola. And if you draw between H you understand graph number 1, everyone? Graph number 1, we understand?
Yes, sir.
Okay. Graph number 2, H and 1 by P. Is H by P. So H and 1 by P, the slope will be equal to H. The third one is the graph between H and V. Small mass, large mass. Graph number 4, H and 1 by V, where V is are we getting these graphs? Yes or no? One
Yes.
graph is drawn between H and P, the other one is H and 1 by P. Okay. Similarly, here, graph number 5, lambda and root over E. The last graph between lambda and 1 by root over E. So just remember these graphs. They'll help you in questions which may be based on graphs. Have you noted it down, bacha?
Yes, sir.
Boys?
No, sir.
Okay.
Completed, sir. Done, sir. Done, sir.
Okay. Now solve this problem. This is a problem that came in one of the previous year JEE when it was IIT-JEE. Read the problem and solve it and give me the answer. Yes. Anyone? It's a simple question. These type of questions are coming these days. So that is why we are doing them. Most of the questions are on this type. And I've got 2 or 3 more. Do it fast. See, remember, everything has to be justified with the time. If you can do faster, I would be able to do more. Otherwise, I'll have to cut short some of them. 2 minutes more. Anyone with an answer, bacha? No one?
A option.
Option A is not correct. Option A is not correct. As soon as you see IIT-JEE, everyone is looking here and there. Remember, whenever you see a question that has come in a JEE, you must get more confidence. You must be confident that since this question has come in a JEE, you should be able to do it nicely, better, because this has to be a simple question, and that is why it came into a JEE. That must be your thought. That must be your thought. If as soon as you see JEE and then you see when you get nervous, that means not everything is good. Should not get nervous seeing the question of a JEE.
Sir, C.
No, C is also not correct. C is also not correct. Everyone is getting everything, but not the correct answer. But what the good part is that we are trying. That is more important. That is more important from where I see. Now, obviously, only B and D are left, so it has to be either B or D, right? Well, I'll give you 1 more minute for everyone because everyone is looking at each other. No one is confident of the answers. The confidence should come. Not confident. Shall I do it?
Sir, B, sir.
B, sir, is correct, sir. How did you do it, sir? Please tell me, sir. Yes, yes, yes. Don't be scared. Chalo, it seems that I have to do it, right? No one is taking the onus, so I'll have to do it. I hate doing questions when students don't do it. But I'll have to do it. It seems no one is ready to understand it. Okay. So here it goes. It is the simplest question in the entire universe because it has come into a previous IIT, so it has to be simple. Difficult question never come in an IIT. So difficult question do not exist. The energy of a photon is equal to the kinetic energy of a photon. Well done. So we write the energy of a photon. What is the energy of a photon? H C
by lambda.
by lambda 1. Yes or no? Lambda 1 is the oh, not by lambda 1, lambda 2. Lambda 2 is the wavelength of the photon. Yes or no? So that is the energy of the photon. This is equal to the kinetic energy of the proton. So what is the kinetic energy of the proton? Half mv square. How do you find the wavelength of the proton? You just have to see what we had just written, the wavelength of the photon. We had written it in different ways. See this way. See this way. H upon root over 2mk. So I will write this lambda as h upon under root of, this is lambda 1, 2mk. But this kinetic energy of the photon is same as the energy. So instead of k, I will just write E. From here, I can find out the value of lambda 2. It is hc by E. This is all maths, beta. I know the value of lambda 1. It is h upon under root of 2me. I have to find the ratio of lambda 1 by lambda 2. You can't find it out? Lambda 1 by lambda 2. So it is h divided by under root of 2me divided by hc by e. What will you have? In the numerator, you will have c. In the numerator, you have root of e. In the denominator, you will have root of m, 2m. All these gentlemen are constant. So lambda 1 by lambda 2 is proportional to e raised to the power of half. Should I tell you, I gave the same question in the NEET wala class and they were able to do it. That means that we are missing something here. Probably we are not very attentive, or probably we are being very casual. See, we just saw the formula now. Once you know this formula, beta, my only task in physics is to tell you that this is the formula for this and this is the formula for this. If you cannot do it after this, that means your maths and the logic part is really not good, not up to the standards. You should be able to eliminate, you should be able to find out lambda 1 by lambda 2 from here. If you don't know this step, it's my fault. If you don't know this step, this is my fault. But both these steps I've already told you. After this step, if you don't know anything, if you can't do it, anyways, please think over it, what we are doing. And see, this question, you have taken more than 5-7 minutes here in the classroom when we have just now read the topic. Now, fast forward to 4 months or 5 months in the future. 5 months before I read something, I would hardly remember it. I have taken 5 minutes to solve this problem now. I will take 10 minutes in the examination hall. In 10 minutes, you will be only doing one question. Remember, whatever your time you take in the class, to multiply it by 2. That is the time you are going to take in the examination hall. Remember it. It's the thumb rule. So you have to do every question in 1 minute. Then only you will be able to attempt all the 25 questions in the examination hall. If you find any question that you're doing 10 minutes to take, forget about that question, because you will not be able to do it in the examination hall. Do you understand the logic, beta? And there are questions which are like this, which can be done in 15 seconds. A good student will do it in 5 seconds. 5 seconds, you look at the question, root over E, done. 5 seconds you'll take for this one. Please try and remember things, note them down, remember them. Otherwise, beta, whatever hard work we are doing, it will not be worth it. Chalo, let's hope that you can do better in this one, and you can expect the same question to be appearing in your paper. Trust me on that. Let's see how much time you take to do this. Because to know how to do it, it's not about whether you can do it or not. It's about how quickly you can do it. Whatever time you take, multiply it by 2. That's the time of your exam. That's the time you will take in the exam. The energy of a proton and alpha particle is same. Then the ratio of their de Broglie wavelength is
Sir, option B.
Option B is correct. Good. Chalo, we have woken up. Well done. Option B is correct. How many students got this answer? Good. How you are supposed to do this? Anyone? The energy of a proton and an alpha particle is same. So you have to remember that formula of energy. Lambda is equal to h by 2 times under root k. Yes or no? The energies are same. This is same, this is same, this is a constant. So basically what it means is, remember I wrote lambda is proportional to 1 by root over m, because I've seen such questions where it actually comes proportional to. They do not talk about momentum, because when we are talking about moving particles, electrons and protons, we do not talk about their momentum, we talk about their energies, and that is the most general form in this question comes. So I know that lambda is now inversely proportional to root over m when energies are same. If you understand this, then lambda alpha, we have to find proton to alpha, sorry. So lambda proton divided by lambda alpha will be under root of mass alpha divided by mass proton. Yes or no? Now the only thing that remains is that you understand what is the ratio of mass of the proton and mass of the alpha, and this is a time we should remember it, because we are into modern physics and we will be encountering many questions based on this. What is an alpha particle?
Helium nucleus.
Helium nucleus. Well done. Proton is proton. Now remember, whenever we talk about such questions, remember these simple things. Mass of a neutron is approximately equal to the mass of a proton. Do we know this?
Yes, sir.
Okay. Mass of deuterium. You know what is deuterium?
Isotope of hydrogen.
Isotope, right. So how many neutrons and how many protons it has in its nucleus?
One proton, two neutron.
2 neutron.
One neutron, two proton.
Two
If it has
proton,
2
one
proton,
neutron.
it is no longer hydrogen, my dear friends. 2 proton cannot be hydrogen, it becomes helium. 1 neutron and 1 proton. Okay. So it is 2 times the mass of a proton. Do we understand this? Helium nucleus, we are not talking about helium nucleus, we are talking about helium nucleus. So this is alpha particle. 2 neutrons, 2 protons, 4 times MP. Do we understand this?
Yes, sir.
Now it is very simple. So this is under root of mass of alpha is 4 times the mass of proton divided by the mass of proton 4. So the answer is 2:1. Do we understand this? Remember these small things. It will help you in getting away with such questions. Got this? Now I've seen one more question. So if I have seen one more question, then I will have to tell you about that question also. Have you noted this down, everyone?
Yes, sir.
Now just note this one as well, because I've seen a question, so I should give you that formula as well. Now this neutrons, when we talk about, if you increase the temperature, this kinetic energy also increases. Yes or no? Do we understand this? So The kinetic energy increases with increase in temperature of the neutron. So when we talk about this energy of this neutrons or any particle, when sometimes they might give you the temperature wala question. So this temperature wala question is basically given for neutrons, and they will give you the de Broglie wavelength at one temperature, and then they will ask you the de Broglie wavelength at any other temperature. So remember, for neutrons, you can write this formula as well. So the de Broglie wavelength of neutron can be written as H will be under root of 2mk. K is the kinetic energy. Now this K cannot be replaced by EV because neutron is neutral. It cannot be accelerated by an electric field, but you can change the temperature, then you can change the kinetic energy. So you can write this formula like this: 2m small k into capital T. This small k is the Boltzmann's constant. Now you may not know this Boltzmann's constant. Have you heard about this Boltzmann's constant?
Yes, sir.
Yes, sir.
Boltzmann constant multiplied by T, and this T is absolute temperature. When I say absolute temperature, I took your class, right? When I say absolute temperature, I mean temperature on the Kelvin scale. Do we understand this?
Yes, sir.
Okay. So since I have seen this, I was not planning to tell you this formula because I had never seen a question on this. But since I saw a question from one of the previous year JEE papers, a very random question, way back 2005, I saw 2005. I'm having the list. I saw this question. So since I saw this, there's a remote possibility that this can come. So if there's a remote possibility, then I cannot leave that remote possibility even. So now this is the question, I think from 14 or 15 or maybe 5 JE. It's written JE, is not written which year JE. From my what should I question bank? It's written JE. This is the question then. This question has come, and that's why that formula. We'll do it now. The de Broglie wavelength of a neutron at 27 degrees Celsius is lambda. What will be the de Broglie wavelength at 927 degrees Celsius? Just bacha.
So lambda by 4.
Not correct. Lambda by 4 is not correct. Lambda for neutron is inversely proportional to the absolute temperature beta. Now can I have the answer? Yes?
Yes, sir.
A, lambda by 2.
Yes, sir.
Yes, that is the correct answer. So lambda at 27 degrees Celsius is already known. I have to find a lambda at 927 degrees Celsius. So let me call this as lambda 2. Lambda 2 divided by lambda 1 will be under root of T1 divided by T2. T1, the first temperature is 27 degrees Celsius. 27 degrees Celsius is only given because 273 plus 27 becomes your 300. And 927 is given because 927 plus 273 becomes 1200. Tongue, 1 by 4. The root becomes 1 by 2. So lambda 2 becomes lambda 1 by 2. Do you understand this? You should not write lambda here because I've written. Do you understand this? Yes or no?
Yes, sir.
Okay. Chalo, next one. Fatafat. Everyone got this? Noted this down?
Yes, sir.
Wait a minute, sir. Done, sir.
This one. Let's say if you can do this one. Remember to the language of the question. The de Broglie wavelength of a vehicle. How can you calculate the de Broglie wavelength of a vehicle? Well, you can calculate the de Broglie wavelength of anything that is moving. The de Broglie wavelength of a vehicle is lambda. The load is changed. Load is changed. Load is changed. Such that its velocity and energy both are doubled. What is the new wavelength? Yes, my dear friends. Anyone? Or shall I do it? How you can double both the velocities and energy? Remember, the main heading is here. Remember, when you're reading a question, you might miss the most important point. Yes, what is the answer? Shall I do it?
Option B, sir.
Option B, sir, lambda by 2. How did you get it? Lambda.
Lambda inversely proportional to velocity.
It is also inversely proportional to root over E. Should you keep that in mind?
Yes, sir.
Then how did you get it? The answer lambda by 2, sir. What has changed here? I have changed something. The velocity also changed. The energy also changed. What I have changed is what is marked in green. What I have changed?
Mass.
Is the mass, my dear friend, is the mass. So I have to eliminate mass from this equation. Mass is h by lambda v. Mass is also, let me write the equation for kinetic energy. Remember, questions are framed in such a way that you get kinetic energy is half mv square. So I also eliminate mass from here. So I can write mass as 2k by v square. Do you understand what I'm doing here? Trying to eliminate mass. So h by lambda v is equal to 2k by v square. V gets cancelled. Lambda becomes h v by 2k into v. Remember, my dear friends, h and 2 are constant. So I get this new equation, which I can't give it to you because such question may not come. It's proportional to v by k. Are we getting the point, beta? Velocity becomes double and kinetic energy becomes double. What happens to lambda? It remains same. So the correct option is option A. Do we understand this, or this has gone above our head saying bye bye? I'm going. Don't worry about me. Huh?
Yes, sir.
Remember, if you remember simple things, and if you miss this small point, load means mass has changed, so you have to eliminate mass from the equations. Okay, before going and finishing of this class, this is one of the questions from my IITs during my time. There was no JEE Main, there were no JEE Advanced, there were only IIT-JEE. Let's see if you can crack this question. Tell me if you can do this. In that time, these questions were alien because we had never seen what is this. So this is the question. A particle of mass m at rest decays into two particles of mass m1 and m2. Spontaneously decay. M1 and m2 having non-zero velocities. Well done. The ratio of de Broglie wavelength of particle lambda 1 and lambda 2 is. So to find the ratio of lambda 1 and lambda 2. And I will ask you this question. Who has solved it in the next class? So note this question down. This is IIT-JEE. And it can very well come back. So if you have done it before, you can straight away take the answer and stay happy. So note this question down and we'll discuss it in the next class. If you have any doubts, I'm always there. Take care and have a nice day. And I've sent you the sheets. Concentrate on those sheets. Okay? Bye-bye.
Option A.
Beta?
Option A, sir.
Option A is not correct.
Sir, option D, sir.
Option D is also not correct. So you are not left with B and C.
Sir.
Yes.
Sir.
Yes.
Sir, what is option D, sir?
Root over M2 by M1 or M1 by M2 is wrong anyways. Whatever is there, forget about it. You can take it root over M2 by M1. You can take it root over M1 by root over M2. Doesn't matter, it's a wrong option. Doesn't matter, it's the wrong option. Okay? Chalo then. I'll see you in the next class. Take care.